Hi, welcome back. In today's video, we're going to talk about polymorphism. Polymorphism means many forms. In Python, polymorphism allows different classes to define the same method name, but with different implementations. Why do we need to use polymorphism? It helps us to use our code in a better way. It improves our code actually. It promotes code reusability, in other words. It supports flexibility in program design, allows different objects to be treated uniformly. And there are different types of polymorphism in Python. The first one of which is method overriding, or let's say runtime polymorphism. The second one is method overloading, meaning that you can use default arguments. And in the third one, it's operator overloading. The fourth one is polymorphism with functions and objects. Then we discuss polymorphism with abstract classes, and finally we talk about doc typing. Sorry. So these are the main topics in Python that we can discuss polymorphism. In this section, we're going to dive deeper into the concept of polymorphism and go through all these methods one by one, all these types of polymorphism, one by one, and provide coding exercises. Thank you for watching. Hi, welcome back. In today's video, we would like to write a program that demonstrates method overriding in a parent vehicle class and child classes car and bike. So we discussed that there are different types of polymorphism. In this video, we are going to have a coding exercise in which we are working with overriding. Here is our class called vehicle. It has a function called start. And whenever this start function is called, we are going to show this message, starting the vehicle. Okay? Then we are having another class called car, which is a child of the vehicle class, or we can say it is derived from the vehicle class. And it also has a function called start. And whenever this start function is called, we are going to have this message, car starts with a key. Okay. And finally, we are having the third class called bike, which is derived from the vehicle class. It has a function called start again, and it is going to print bike starts with a button. Okay. So as you see, these two classes are derived from the vehicle class. So the vehicle class is our base class, or let's say parent class. And each of these classes are having a function with the same name. Actually, this means we are overriding the parent class because the parent class has a function called start, but the child class has a function with the same name. And I would like to now create an object of these two children's, okay? The V1, which is my first object, is created from the class called car, and the V2 object is created from the class bike, okay? Then we would like to use these two objects to call the start function. But which start function is going to be called in this situation when we are having overriding? Okay, when we are having overriding and we are creating an object from the car class, and when we use that object from the car class to call a start function, this start function is going to be called and not the parent one. And this is overriding actually because we are having a child class derived from the parent class and they're having a function that they are having the same name, identical names. Therefore, Overriding means you have uh, the two functions with the same name. So we are overriding the main function that is inside the parent class. Okay. So here I use the object of the car class and I call the start function, and we expect that this car starts with a key message is going to be printed. Then I use the second object to call the start function again, and here we know that v2 was created from the bike class, and when we use that object and we call this function, we expect to have this in the output. Bike starts with a button. So when I run this code, we see car starts with a key message is shown in the output, which is this one from the car class, which is derived from the vehicle class. And also then this bike starts with a button message is shown because it is the print of the start function, from the bike class, which itself is derived from the vehicle class. So this is how we can implement overriding method in Python, that we have a parent class and, for example, two children classes, and inside the children classes we are having functions with the same name as the parent class function. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about overloading a function to calculate area. Here we are having a class called shape. In this shape class, we are having only one function. This is my function called area. It requires two arguments, length and breadth, apart from self. And we are putting breadth equals to none. And then if breadth is none, this is the if condition. We are defaulting this argument, okay? And now we're saying if breadth is none, then return the output of length multiplied by length itself. And we realize that our shape is a square. Otherwise, if the breadth is not none, come to this else part and return length multiplied by breadth. And it means that our shape is a rectangle. But what does it mean? We would like to overload this function. So if we call this area function and we pass only one argument, it will be the length argument. And in that situation, the compiler is going to by default consider breadth to be none. And here we are checking, okay, now that breadth is none, multiply length by itself. Okay, so it's a square. However, if we called this area function with two arguments, the first one is length and assign the second one for the breadth, and then you check breadth is not no, because there is a number assigned to it, because we had an argument about that when we called the function. Therefore, come to this else part and multiply length by breadth. Okay, let me illustrate it with an example. It will be easier. So we are creating an object of the shape class here. I call the object S. Then I'm calling the function saying that area of a square, and I use the object s.area, the name of the function, and in parentheses I write down number 5. So I'm having one argument only. When I call this area function, the compiler runs this area function and it has one argument only. So length equals 5 and we have no other arguments. Therefore, breadth is by default assigned to none. And because it is assigned to none, we check it here. Breadth is none. Is it true? Yes, this statement is true. Therefore, return us this value, length multiplied by length. So 5 multiplied by 5 is 25. It is returned here. It is returned. And then because we are inside the print function, it is going to print 25 for us. Then I try to call the function one more time. I mentioned this message, area of rectangle. Then I call the area function. This time I'm having 2 arguments. So the 5 equals length and the breadth equals 10 this time and not none. Okay, it will be equal to none only if we have no argument provided for that. So if I call the function with one argument, it means that breadth is assigned to none by default because we are putting it there. However, if we have the call of the function with 2 arguments, the second argument, which is 10, is going to be assigned to the breadth, and then we check if breadth equals none. No, this statement is not true because we assign number 10 to it. Then, okay, go to this else part and return length multiplied by breadth, which means that 5 multiplied by 10. So when I run this code, we see the output here. It says area of a square, and then 25 is printed. Then area of rectangle, then number 50 is printed here in the output. Actually, this is a very good example of learning how overloading a function for calculating the area of different shapes would work in Python, and how in fact they are being implemented in Python easily. Thank you for watching. Hi, welcome back. In today's video, we are going to do another coding exercise about overloading. Here we are having a class called printer. In this class, we are having a function called display. So this is the only function of our printer class. This function requires 2 arguments, text and number. And number by default is assigned to none. So now we are going to do certain things in this function, but we're going to get back to this function later. But let me explain this function through an example. Here we are creating an object from the printer class. I use that to call the display function, and I am having only one argument called hello. When I go up, this function is called with one argument, which is hello. So this is assigned to text. A number is by default assigned to none. And here we are checking to see if number is none. If it's true, which is the case, we are going to enter this if condition, and this part is going to be checked now. And here we are checking to see if the variable text is of string type. Is it? Yes, because we are having a string here. So if this is true, print the text for me in the output. So hello is going to be printed. Let me repeat it. We call the display function, and we are having only one argument. This argument is assigned to text, and the second argument is having a default value, which is called number, and number is assigned to none by default. Then we check if number is none. In this case, the number is none because we are having only one argument, and that is assigned to text. So the default value for number remains the same. And we check, okay, if number is none, yes, then it enters this part. And then we need to have the checking of this if condition. We check if this text variable is of type string here in this line. Okay. Then if this is true, we are going to print hello. Otherwise, if it was not true, we were going to print the number. Let me call the display function with another argument. So now I call the display function one more time, and this time I'm having the argument as a number and not a string. It's 100, the argument. So this display is called, display function is called. And now, because we are having only, again, one argument, this 100 is assigned to this argument, this parameter here, text, and not this one. This one will be activated only if we have two arguments, because it is the second argument. Okay, don't get confused that the name of the parameter is number. So this is the second argument, and if we were having a second argument, that second argument would have been assigned to the number parameter here. We are having only one argument, and the argument is going to be assigned to text. Here we are checking if number is none. Yes, number is still none because we didn't have a second argument. Then we are going to enter this part, and we are checking this if condition. Now we are going to check if this text parameter or variable, let's say, is of type string. Is it true? No, this time it's not true, because it's 100 is not a string, it's a number. Because this condition is not true, then this part is not going to be executed, and the else part is going to be executed, and we are going to print number message, and then the number 100 is going to be printed in the output. Now, what happens if we are having two arguments? If we are having two arguments, is my example here. So hello and 100. We're calling the display function. Hello is assigned to text, and 100 this time is assigned to variable called number, because here it is the second argument. We check if number is none. No, number is not none anymore. None was the default value. This time it is 100. So it directly comes here to this else part, and it says text hello number 100. So when I run this code, we see exactly the same thing as we discussed here. We can see that in the first time when we are having only one string, the hello text is being printed. So text is assigned, this hello is assigned to text. Number is none, yes. So is it a string? Yes. Therefore, type down text and then hello. This is text and then hello. Okay. Then we call the display function with 100. 100 is assigned to text. Number is none. Yes, it is still none. The text variable is holding a string. No. Then go to this else part and print number, which is 100. Number 100. Okay. And finally, call the function with two arguments here. And hello is assigned to text, 100 is assigned to number. Check if number is none. No, it's not true. Then it goes to the else part, and it says text, hello, and number 100. So this is basically how we can have an overloading method in Python. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about operator overloading. So operator overloading allows us to redefine how operator like addition, subtraction, multiplication, and division work for custom objects. In simple words, it allows objects of a class to use operator just like the built-in data type, numbers, strings, for example. So for example, here 2 plus 2 equals 4, okay? Operator overloading allows me to have two objects, for example, object 1 and object 2, to add these two. So object 3 equals object 1 plus object 2. So the operator overloading is this concept. So we can use these operators for objects. Okay, so in order to illustrate it with an example, here is my class called money. It has a constructor, and whenever we create an object of the money class, that argument for this constructor is assigned to the attribute of this constructor, self.amount. Okay, so it is initializing our attributes, in fact. Then we are having two overloaded functions here. So the first one is overloaded add, and the second one is overloaded str. Okay. So using this overloaded add, we can add two objects, and using this overloaded str, we convert the object to a string for printing. Let me illustrate it with this example. Here I create the first object called wallet1, and it is from the money class, and we are having this number. Okay, so the amount is 50, and amount is assigned to our attribute here. Okay, so we are initializing our attribute for the first object. Then we do the same for the second object. However, the amount is 30. So the first one was 50 and the second one is 30. Now we would like to create the third object, which is the wallet1 plus wallet2. So thanks to operator overloading, we can do that. Otherwise, it's not possible to do that. So when we are having wallet1 plus wallet2, automatically the compiler is going to use the overloaded add, then have this self.amount plus other.amount. Okay, so the self and other. So two operators, two values for two different objects are being added to each other, and it is going to return that for us and assign to wallet3. So for example, if I remove this part and I compile, we see that there is an error. Okay, there is an error here. So we cannot do that. It says unsupported type for plus money and money. Okay, so it's not possible to do that because we cannot add two objects to each other unless we are having the operator overloading. So this will help us to add the value of these two objects and assign it to wallet3 objects. Okay, so this is how the operator overloading works with the add, for example, overloaded add. Then in order to convert the output of this wallet3, we need this overloaded str. So when I run the code now, the overloaded add is there. When I run the code, we see that 80 is shown in the output. Okay, so this 80 is shown in the output, and the dollar sign comes from here that we are having it here. So dollar sign and then self.amount is being printed for the value of wallet3. But if I also remove this part and recompile, we are printing the memory address of this object wallet3. You see? So it is the memory address that it is stored, but we need to convert this object to a string so we can see what is the value that this object is holding. So when I have the overloaded str, it's going to help me to see actually its value. And basically this overloaded str is returning simply the dollar value, the dollar sign, sorry, because we are talking about dollars here. And then we are simply typing down self.amount. So the attribute that is assigned to wallet3, which is the wallet1 plus wallet2 from the overloaded add, is going to be shown in the terminal. So this is how actually we can use operator overloading to add the two objects to each other to assign to the third object, for example. And there are different operator overloading. There are subtraction, multiplication, division, equal, larger than, lower than, etc. We try to cover some of them in the following videos for your practice. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about operator overloading. So we would like to add, for example, two objects to each other. Basically, it's not possible to do it unless we're using operator overloading. Here we are having different operator overloading in this coding exercise. Here is my class called box. Here is my constructor, which is going to assign the argument as my attribute here. We are having overloaded add, that it is going to add two items, or let's say two objects. We are having the mul, overloaded mul or mul, that we are going to use for the multiplication. Then we are having the GT, overloaded GT, or greater than, let's say, to compare if one item is larger than the other. And it's going to give us the result as the true or false. Then we are having the overloaded str to show the to convert the object into a string so we can show it in the output. Here we are creating object box1 and object box2 from the box class, and we are assigning two numbers, 10 and 20. So 10 and 20 are initialized and assigned to our attributes for box1 and box2. Now we would like to use overloaded add. So we have the box3 equals box1 plus box2, and we are printing box3. Basically, we expect to have 10 plus 20, so the output will be 30 here. So when I run this code, I see box with 30 items is shown in the output. Then we are having the call for the multiplication. So overloaded mul is going to be called. Here we are having the box4 object equals box1 multiplied by 3. So whatever that is inside the box1, which we assign to be 10, for the attribute using the first object, we are going to multiply it by 3. So 10 was the argument that we assigned to initialize our attribute using the first object, box1. Now we are using the same object and multiply it by 3. And this is done through this overloaded mul. Basically, it is going to have the attribute multiplied by the number that is here, okay, in the mul, overloaded mul. Then we are going to print this box4, and for that we are going to use the str. We are saying that box with, and then the number is being printed, items. So here we expect to see also 30 because this one is 10 multiplied by 3. It will be 30. So box with 30 items. Finally, we would like to compare two boxes, box 1 and box 2. In order to compare, the compiler is going to use overloaded greater than or overloaded GT, and we are going to check if the first one is larger than the other. If it is true, it is going to return true. If this is not true, it is going to return false. So we are having box 2, which is 20, and box 1, which was assigned 10 for its attribute. So we are basically saying that 20 is larger than 10. Is it true? Yes. Therefore, we are having the true in the output. If it was not true, we were going to have the false result in the output. So in this coding exercise, we learned to work with a few of operator overloadings in Python. We have a constructor here that is assigning our parameter to our attribute. Then we are having overloaded add. So two objects are being added. Then we are having overloaded mul. So the value of the attribute stored using one object is multiplied by a number, for example. Then we are having the greater than overloaded, where we compare to the value that is stored using two objects, okay, to see if the first one, for example, is larger than the second one or not. So we are going to have the result of output as the true or false. Then finally, we again have this str to convert the object into strings so we can have these beautiful messages in the output. Thank you for watching. Hi, welcome back. In today's video, we're going to talk about polymorphism with functions and objects. Here is my class called dog. And then inside this class, we are having a function called sound. And whenever this sound function is called, this message is going to be printed. Dog barks, okay? Then we are having another class called cat, and whenever this function sound is called, that is inside the cat class. This message is shown cat mews. So this is the cat class. Inside that we are having only one function again called sound. And then when this sound is called, this sound function is called cat mews, message is going to be printed in the output. Okay. Then we are having a polymorphic function that is going to work with different objects that we call animal here, for example. Okay. And using that object, we are going to call the corresponding sound function. So sound function was something in the dog class and the cat class. Okay, but how can we work with this polymorphic function? Let me illustrate it with an example. Here, I'm having a list of different animal objects. Okay, so a list containing instances of dog and cat, our classes. Okay, so here before that we were having, for example, animals equals the name of the name of the class and then empty parentheses. Okay, this is how we can use we can create an object of the dog class. But here we are having the same name, but it's a list containing objects of two classes, dog and cat. Okay, so it's a list of objects, or let's say instances of dog class and cat class. Okay, then we are going to iterate through this list. In order to iterate, we are having a for loop. So we are saying our iterating variable is called animal, let's say. And we are saying for each animal inside this animals list, just call the make sound function and pass the object, the animal. Okay. So let me illustrate it here. We are going to loop over this list, and it has two objects inside of it. So basically what we are going to do, we are going to have the make sound function to be called. The first time the make sound function is called, and inside parentheses we are going to have the animal. And this animal is the object that created from the dog class in the first iteration, because the first element in this list is relevant to the dog class. And then we are going to call the make sound function again with our iterating variable that is called animal, but this time animal equals the cat. So it is like this. So animal equal dog. And here it's like animal equal cat. Okay. So we are iterating through this list. It has two elements. In the first iteration, we are calling the make sound function with the animal object, and the animal object in the first iteration is declared like this to be an object of the dog class. In the second iteration, it is an object of the cat class. So when we call this function, what happens? We're calling this function and passing the object. And that object is used to call the sound function. So in the first iteration, because animal is an object of the dog class, we are having animal.sound. Therefore, this sound function is called, which is from the dog class. And in the second iteration, animal object is from the cat class. When we call the make sound function, we are passing that animal object from the cat class. And then we are using that object to call the sound function, which is inside the cat class this time, because we are using an object of the cat class. So cat mews is shown in the output. So when I run this code, we see dog barks and cat mews. Okay, so firstly, this function is called as we expected and explained. And secondly, this function is called and this message is printed in the output. So this is how actually in Python we can work with polymorphism with functions and objects. So let me review it one more time. We have a class called dog. It has a function called sound. Whenever this sound function is called, this message is being printed, dog barks. And we are having another class called cat. It has the same function name. And whenever this sound function is called, this message is printed in the output, cat mews. Then we are defining a polymorphic function that works with different objects, okay? But before diving into this function, we are going to talk about what we do here. So we are creating a list of different objects of the dog and the cat classes. And then we are iterating through that list of objects. So for each animal in this list, we are calling the make sound function and pass the object as argument. So in the first iteration, we are going to have like initializing an object like this. So animal equals dog, which is the way that we were using so far to create an object. So animal is now an object of the dog class, and this is used, this animal is used to call the make sound function. So make sound function is called, and that animal, which is an object of the dog class, is passed. So we are using that object to call the sound function, which is this function, and dog barks is printed in the output because whenever the sound function is called, dog barks message is shown in the output. Then we are having the second iteration where animal equals the cat. It means that we are creating an object from the cat class. And then we are passing it to this make sound function. And we are using the object of the cat class to call the sound function, which is this function. And it says cat mews. Okay. And this message is shown in the output. So this is how actually we can work with polymorphic functions and also having polymorphism with functions and objects. Thank you for watching. Hi, welcome back. In today's video, we are going to talk about doc typing. Here is my class called car. It has a function called start, and this function is going to print car starts with a key. Then we are having a class called bike, and it has also a function called start, and it prints bike starts with a button. Then we are defining a polymorphic function that works with any object having a start method. Okay? Because inside this function, the argument is an object, and basically using that object, we are calling the start functions, okay, in different classes. Now we would like to create an object. In order to create an object, we can do it like this. So this way, we are directly calling the start vehicle function with an object of the car class, and this way we are calling the start vehicle function with an object of bike class. Basically this part, car with empty parentheses, this creates an object of the car class. It's the same as this one. Okay, it's the same as this one. Car underscore object equals car. So we used to create an object like this, but using it here, it's exactly as the same as this one. So we are creating an object of the car class, and then we pass that as argument for the function start vehicle. So the start vehicle function is called with that object as argument. We are going to use that object to call the start function. So because the first argument is from the car class, this start is going to be called car starts with a key. So this message is shown in the output. Then We are creating an object of the bike class for the argument, and we call the start vehicle function. And in this function, again, we are going to use that object of the bike class to call the start function, which will be this start function this time because we're using an object of this class. And it shows this message: bike starts with a button. So this message is printed in the output. This is how we can actually change the way that we are creating an instance or an object from a class, and this is how a polymorphic function work with any object that have a function called start inside that class. Thank you for watching.